Okay. Oh, there was another one I wanted to do too. I'll have to tack it on at the end. Okay, let's solve this DE. First thing we want to do, step one, solve our homogeneous version. Homogeneous means something completely different. It means your milk is well mixed. This is pronounced homogeneous. So just keep that in mind. Don't listen to anybody that says homogeneous. Homogeneous doesn't have this extra E right there. So we solve the homogeneous version, y double prime minus 4y prime plus 5y equals 0. We should be at the point now that we can jump straight to the characteristic polynomial. We assume y equals e to the lambda t. We'll use t. Yeah, they're using t. So if we plug all that in here, we're going to get our characteristic polynomial that looks like this. You can check all the details. You can find y prime and y double prime, factor out the e to the lambda t. You can check all that. This is what you're going to get. That's a minus right there. Look, minus. That factors. That's lambda minus 5. Lambda plus 1 equals 0. Okay, yeah, this is the one I was interested in. So we get two solutions. Lambda equals 5. And negative 1. So that means my complementary solution is y equals C1 e to the 5t plus C2 e to the negative t. Now, the question that we're solving didn't even ask for that. The question's only asking for the particular solution. So did I technically need to do this? Yes, I did. I still have to go through all this math to make sure I'm not reusing any powers on E. So here, when we're trying to find step 2, our particular solution, we look for a function that has the same form as what's over here. So my first guess would be yp equals a e to the negative t, because that has the same form as what I have. Unfortunately, that won't work here. I can't use that. I've already used up e to the negative t right here. That's why we have to solve the homogeneous version first to make sure whatever we're plugging or doing over here isn't something we've already used up. And here it is. That won't work. So I need to add on extra t's. I keep adding extra t's until I get something linearly independent. So my second guess would be at e to the negative t. That's linearly independent from both of these other solutions. And you'll see that it will work. Okay, well, if that's yp, so I'm coming around here, then yp prime, I'm going to have to do product rule there, will be a. Yeah, I'm going to factor the a out. Negative t plus t times negative 1 e to the negative t. So what is that? That's a e to the negative t minus t e to the negative t. And I forgot my a right there. There's my a. Okay, that's y prime, y double prime. That guy I don't need a product rule on. That's just negative a e to the negative t. I'm going to factor out this negative a And just do product rule on that. Derivative of the first times the second, plus, leave the first alone, derivative of the second. Pick up that extra negative. Okay, I got a bunch of negatives in here, so I got to be careful. So I'm going to have another negative. That's the same as that guy right there. So I'm just going to call that -2 of those. And then I'm going to have a negative times a negative. So a plus AT e to the -t. Okay, now I plug these all in to the DE to the original. Plug them in here and solve for A. We need some extra space. I'm going to make all this a little smaller. All right, so let's plug all this in. So I got y double prime plus or minus 4 times the derivative. So I'm going to have a -4 a e to the -t plus 4 at e to the -t minus 5 times the original. That's that guy. And that's supposed to equal 2e to the -t. In order for that to happen, all these guys with the AT, all the guys with the extra t are going to have to end up canceling out. If these guys right here don't end up canceling out, something's going to be wrong because I don't have anything that looks like t e to the -t on the other side. But look, they do. I've got 1 plus 4 minus 5. Those all canceled out. So I just get -6 a e to the -t equals 2 e to the -t. So that means A must be -1/3. So my particular solution I was looking for is -1/3 e to the -t. And that's all the question asked for. Oh, wait, I forgot my extra t. So that's what I would type in. The question didn't ask for the entire general solution, just this particular solution. I'm going to go ahead and write it though, because that's what I would type in. I'm done. But for completeness, the full general solution is the complementary solution plus the particular solution. So that would be C1 e to the 5t, C2 e to the -t minus 1/3 t e to the -t. Okay, now let's do one of these higher order DEs where we have to use synthetic division or long division or something like that. Rational root theorem, all that. So this is a homogeneous. So this is third order homogeneous. That's an O. Constant coefficients. So I debated with like this problem here. There are like 2 or 3 of these in the homework. Honestly, they kind of need their own homework. They don't really belong in undetermined coefficients. That's the title of this homework, is undetermined coefficients. I'm not using undetermined coefficients on here at all. So those problems, I guess I could have put them here. But since we're covering them the same week, I kind of slipped them where I thought they fit the best. I just want you to keep in mind, we're not using undetermined coefficients here at all. We don't need to. We don't need a particular solution. Our other side's already 0. No. We want to assume that y is e to the lambda t. I'll go through all the gory details here. Y prime them is lambda, e to the lambda t, double prime, lambda squared, and y triple prime, lambda cubed, e to the lambda t. We'll plug all that in here, and we're going to get lambda cubed minus 7 lambda squared plus 14 lambda minus 8 equals 0. E to the lambda t never equals 0. So we get this cubic equation. It's our characteristic polynomial. So that's our goal. That's I guess, the hard part of this problem. This is the crux of the problem here. Finding the roots to this third degree polynomial. We can't just use quadratic formula. There is a cubic formula. There's even a fourth degree, but they're really complicated. You could Google how to the cubic equation, but it would take like 2 pages just to write down the formula. So we're not going to do that. We're going to use the rational root theorem to guess at some roots. Now, these problems are all set up so that all the roots, I shouldn't say all the roots, at least one of the roots we'll find using rational root theorem. Then we can reduce this and turn it into a quadratic. And if nothing else, we could use quadratic formula to find the other 2. We know we're going to have 3 roots because it's a cubic. Okay, so we list all possible rational roots. Again, you're going to have a group assignment exactly like this. This is the work I want to see. And that's factors of the guy at the end. Don't worry about the plus or the minus, over factors of your leading coefficient, the guy at the front. So anything that goes into 8, plus or minus 1, 2, 4, or 8, over factors of 1 are just plus or minus 1. So we get this whole long giant list of possible fractions. All the possible fractions I can make out of things on top over things on the bottom. Sometimes that list is really, really long. And we just start trying. We literally just guess and check, start trying some of these and find one that works. It's funny, I wrote find 1 and I wrote the number 1 that works. 1 works, the number 1 works. So if I check lambda equals 1, that's always the first thing you check. 1 cubed minus 7 times 1 squared, that's a 1. Plus 14 times 1 minus 8, that's 15 minus 15, that's 0. 1 works. So that means lambda minus 1 is a factor. That's the factor theorem. If you know a root, you know a factor. So we're going to factor that out. So we could use long division or synthetic. Maybe I'll do it both ways just to refresh you on how to do them. Here's long division. So I would do lambda minus 1 divided into so we're looking for, I don't know why it just did that. Oh, there it goes. What do I got to multiply lambda by to get lambda cubed? That would be lambda, that looked like a 7. Lambda squared, distribute, lambda cubed minus lambda squared. Draw the line, change the signs, add straight down, those cancel out. I get -7. Bring down the next guy. -7 lambda. So -7 lambda squared plus 7 lambda. My 7s and my lambdas are definitely looking too much alike here. Draw the line, change the signs, add straight down, those canceled out, they better. I mean, so what went wrong here? Pause this a second. Okay, as soon as I got here, that I was not going to get 0 as the remainder. I knew something was wrong. I done goofed right there. -7 plus 1 is not -7. Right here, -7 plus 1 is -6. Bring down the next guy. So this will be -6 lambda. So distribute plus 6 lambda. Draw the line, change the signs. These cancel out, they better. And then this will be 8 lambda minus 8. So here I'll have plus 8. So distribute 8 lambda minus 8, draw the line, change the signs. I get a remainder of 0. You better get a remainder of 0 or you've done goofed. So that means that that third degree polynomial is really lambda minus 1, lambda minus 6 lambda plus 8. But that factors again. That's a quadratic. That factors again. We can do that one in our heads. We don't need to go through all this math again. We'll just factor it. That's lambda minus 2, lambda minus 4. So we know our factors, we know our roots. Our roots are lambda equals 1, 2, 4. So that means my general solution, I just take the linear combination of all these guys. Okay, and then I told you I would also do it by synthetic division. So here it is with synthetic. You know, synthetic division doesn't always work. It only works when you're trying to divide out a linear factor. When this guy out here is first degree, that's the only time you can use synthetic. I never liked synthetic. When I was growing up, I never used it. I would always go through the long division. But now as I'm getting older, synthetic is a lot faster. It really is. So for synthetic, we just write our coefficients here, which were 1, I've already forgotten, -7, 14, and -8. Yeah. Write your coefficients. My root was lambda minus 1. So I write the root here, not the negative 1. It's always lambda minus the root. The root was 1. Okay, first guy you just bring down. And then it's multiply and add all the way across. Multiply. 1 times 1 is 1. Add straight down. Multiply. 1 times -6 is -6. Add straight down. Multiply. 1 times 8 is 8. Add straight down. There's my remainder of 0. If you don't get a remainder of 0, you've done goofed. Now you got to figure out what powers go on these guys. So this was 3rd degree here. Once you've divided out a linear factor, this must be 2nd degree. So you got to kind of work backwards here and go, oh, if that's 2nd degree, that must be lambda squared minus 6 lambda plus 8. And then again, we could repeat the process. We could use rational root theorem to keep trying more roots. Or like it's a quadratic with the quadratic formula, completing the square, factoring, whatever method you like. Find the other roots. Okay, any questions from anyone that's here? All right, that's a good place to stop.